I'm Andrew Smith from the Open University Cisco Academy, and I am going to cover Module 6 Etherchannel from Switching, Routing and Wireless Essentials. As ever, I'm not going to read through the slides, but what you are probably discovering now is how the Cisco content is beginning to hop a little bit between different linked topics. You started off with VLANs, then into VLAN routing, then spanning tree, now Etherchannel, and you'll see the connection here. The joy of Etherchannel is it allows us to use multiple simultaneous redundant links and bind them together on a switch to actually create an aggregation of different channels, different ports, and therefore create a greater bandwidth. So if you had a gigabit connection and you put 2 gigabit connections together, you've got a 2 gigabit connection, 4 gigabit, or depending on how many you bind together. So increased bandwidth, improved redundancy, and therefore hopefully better performance. And we often, when we're creating trunk links, we'll bind them together to be these channels, and then we will actually trunk traffic and VLAN tagging between the channels as well. Like all other videos, I'm going to do a demo at the end of this in a separate packet tracer activity because it takes a little bit of configuration. And for those of you that are studying TM257, and are doing the day school, whether it's your alternate learning experience or in class, keep an eye out. This is a practical activity you will be doing, and it is worth at least developing the skill to build one basic channel between devices. Okay, so you can do the configuration on the Etherchannel interface. So once you've found all of the ports into this channel interface, it becomes its own new pseudo interface. Just like you can configure things on a VLAN, you can configure things now on the Etherchannel interface as well, and therefore the load balancing and everything else takes place accordingly. And the spanning tree protocol treats all of those ports as if it's that one pseudo interface, that one pretend interface. It doesn't span tree across all the cables. It will only span and tree across down that one shared bandwidth pipe. That is a combination of a multitude of channels. You cannot mix cables. You cannot mix interfaces. You cannot mix speeds or duplexing or anything like that. Now, Cisco say that a 2960 layer 2 switch currently supports up to 60 channels. I will actually mention a little bit further along the typical limits, and it is limited based on device, based on iOS, based on firmware, and based on standard as well. But you will need to look up the specification for each port channel and for each Cisco switch. And basically it will run its own auto negotiation. PAGP, PAGP or PAGP is the Cisco proprietary standard link aggregation control protocol. It's the open IEEE standard. And it's useful to know both. Cisco, it will perform better on Cisco devices, just like EIGRP, even though they've made that an open standard now, still performs better on Cisco devices as well. And it will update quicker, it will perform quicker. In context, you've got to go and buy the nice shiny equipment from Cisco, and you can see here a reminder, all ports got the same speed, settings, VLAN information, and as soon as you make a modification that is outside of the channel, it will bring that channel down. Best way to break a channel is to fiddle with something in the ports and cables outside of the channel. PAGP has 3 modes. It's either on, so it will, the Etherchannel will run without PAGP, and it will not exchange, or it's desirable, it's looking that it will run with this, or it will auto negotiate. And the modes must be compatible on each side. So what will happen is you need to set up whether it will make that connection. And why we have these negotiation modes is often structures are recabled, re-engineered, or somebody's pulled a cable out, or cables fail, connections fail. And when that happens, the system's got to be able to actually handle whether it's going to establish this shared bandwidth. If somebody unplugs it and literally connects it to another switch, it doesn't want to have that cable now as part of the PADGP channel. ICP, as part of the IEEE 802.3AD, cunningly named standard, is pretty very similar, and it behaves almost in the same way as PADGP, but obviously it's designed for a multi-vendor network where obviously you are going to be connecting to other manufacturers, switching or routing devices, because routers with switch port interfaces or NIM network modules will be able to handle this as well. And it's got the same, it just talks about active and passive modes. And it's got a range of different negotiative positions. And these are the kind of things you need to memorize for the test. But often in life, this is the thing you will quickly Google when you're troubleshooting, when you're actually working on a Cisco router. An ICP can handle up to 16 ports, 8 active, 8 standby. PADGP can handle up to 8 ports. However, as I've already said, it's very device, firmware and iOS dependent, but you're probably not going to bind typically more than 4 ports on a switch, because if you're binding too many, what's the switch doing? It's got to have the ability to scale and be redundant, have redundant ports as well. Configuring it, as we've now said a number of times, we've got to set up the same speed. We've got to make sure that it's all in the same VLAN or configured as a trunk. If it's not in the same VLAN, it will cause problems as well, and it will then operate accordingly. Okay. For the sort of setup, basically both ends should be mirrored with each other, and if you've got them mirroring, it will run fine. And that way, then you specify the interfaces that are going to be part of there. Make sure they're part of the same channel group, and then you go and configure that port channel. Okay, so this example at the bottom is a good example where they've used the interface range command, quickly told it to tell those ports are all part of the same channel group, and then set it up for trunking and what VLANs are allowed. But you've got to do it exactly the same for the sense of configuration on both sides, so that it will communicate appropriately. It's worth doing the packet tracer activity and actually configuring the link, because it will turn up as part of your end of module assessment if you're one of our Cisco students, and you need to at least build up that talent to practice it, so that you're aware of what the industry requirements are. Etherchannel, you can do the show interfaces port channel or Etherchannel summary or port channel commands as well. There is actually a sort of range of different commands. You can look at the physical interface, or you can look at the actual physical port and its membership. The common issues you're likely to encounter is it's got the wrong VLANs. If you're if you put it as part of a VLAN and part of the interface is in VLAN 10, the other one's in VLAN 20, for example, it won't come up. Or you've set up the wrong trunk, or you've set up the wrong cables or the wrong yeah, you've got different bandwidths, duplexing, or so on, or you haven't got compatible modes on either side. So basically, it is very matchy-matchy. And if you remember that, you'll actually find it's quite straightforward. This scenario talks through a port channel setup for Etherchannel. And yeah, the trick is show Etherchannel summary first. And you can see it'll immediately tell you if the Etherchannel is down, and then you can do the show run and look at your settings. Always look at your config first. Have you mistyped there? Remember, you also got to check both ends. Yeah, what's on one, what's on the other? Does it match? Does it match? Is there any slight differences? Should there be any slight differences? And correct the misconfiguration. If it's still not working, then use the show Etherchannel summary command, and yes, just check that your settings and your config and your cables and your duplexing and your VLANs and everything are set up. And again, there is another great packet tracer activity to do this. So with Etherchannel, either they've got to be part of the same VLAN, or the cables, the ports, and whatever settings have got to be the same, or if it's trunking, it's still set up correctly, and as soon as you make any changes to any individual port, you are likely, possibly, to screw it up. So make sure it's all matchy-matchy and it all mirrors from either end. And hopefully you'll remember that phrase, it's got a matchy-matchy in order for it to work. So thank you very much. I'm Andrew Smith from the Open University, and hopefully you have found this to be very useful.